Transistor. The credit of inventing the transistor in the year 1947 goes to J. Bardeen of W.H. Bartain of Bell Telephone Laboratories, USA. The first junction transistor consists of two back-to-back PN junctions was invented by William Shockley in 1951. Transistor, structure and action. A transistor has three doped regions forming two PN junctions between them. They can be formed as NPN transistor. Here, two segments of N semiconductor, emitter and collector, are separated by a segment of P-type semiconductor, which is called base. PNP transistor. Here, two segments of P-type semiconductor, termed as emitter and collector, are separated by an N-type semiconductor, termed as base. In the schematic symbols used for representing PNP and NPN transistors, the arrowhead shows the direction of the conventional current in the transistor. Let us study the three segments of the transistor. Emitter. This is a segment on one side of the transistor. It is of the moderate size and heavily doped. It supplies a large number of majority carriers for the current flow through the transistor. Base. This is the central segment. It is very thin and lightly doped. Collector. This segment collects the major portion of the majority charge carriers supplied by the emitter. The collector side is moderately doped and large in size as compared to the emitter. In the case of transistor, depletion regions are formed at the emitter base junction and the base collector junction. Working of transistor. The transistor works as an amplifier with its emitter base junction forward bias and the base collector junction reverse bias. When the VCC and VEE are used for creating the respective biasing, when the transistor is biased in this way, it is said to be in active state. We represent the voltage between the emitter and the base as VEB and that between the collector and the base as VC. The heavily doped emitter has a high concentration of majority carriers, which will be holes in the PNP transistor and electrons in the NPN transistor. These majority carriers enters the base region in the large number of holes entering the base from the emitter sends the small number of electrons there. The base is made thin so that the most of the holes find themselves near the reverse bias base collector junction and so cross the junction instead of moving to the base terminal. If we represent the hole current and the electron current crossing the forward bias junction by IH and IE respectively, then the total current in the forward bias diode is the sum of them, that is IH plus IE. We see that the emitter current, that is IE, equals to IH plus IE, but the base current IB is very less than IH plus IE because a major part of the IE goes to the collector instead of coming out of the base terminal. Let us take current emerging from the base terminal as IB and that from the collector terminal as IC. Then by the application of Kirchhoff's law, IE equals to IC plus IB. We can also see that IC is approximately equals to IE. From the above description, we can conclude that in the active state of the transistor, the emitter base junction acts as low resistance, while the base collector acts as high resistance.